All right. Now we are going to talk about something very interesting. That is electronegativity. Electronegativity. We are going to talk about electronegativity. Electronegativity. Now, what is electronegativity? Something you have learned in your O levels. What is electronegativity? It's the ability of an atom in a molecule to attract electron itself. What is electronegativity? This is something you have learned in your O levels. It is the ability of an atom in a molecule to attract electron itself. That is the definition of electronegativity. So as you have learned in O levels, when you go left to right in a period, what will happen? The electronegativity will increase. Let's talk about the period 2. You have lithium here, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. Okay, so when you go left to right, what will happen? The atomic radius will decrease. So the distance between the nucleus and the outmost shell will be decreased when you go left to right in a period. So when the length or the distance between the nucleus and the outmost shell, when the length is decreased, what will happen? The attraction will be increased. As I mentioned before, the electronegativity means it's defined as uh, the ability of an atom in a molecule to attract electron itself. So when the size decreasing from left to right in a period, the electronegativity will increase. That is what's going to happen. So it's a very interesting thing, no? Right? Okay. Now, even though even though elect even though electronegativity is defined as that, so when sometimes the amount of electronegativity, okay, the amount of electronegativity is decided by some other factors. In your A levels, in your examination, there's a very wonderful question. Now, there's a wonderful question which asked frequently from you, that you have given some molecules and you will ask to order them in ascending or descending order by the electronegativity. Now we are going to talk about how we are going to determine the electronegativity of an atom in a molecule. Okay, I'll get example. Let's say a CH4, methane, and carbon dioxide, and I'll use acetic acid, CH3, C double OH, uh, and uh, and formic acid. Okay, formic acid. Okay, formic acid. Okay, now there are 4 molecules. Methane is here, carbon dioxide here, and carboxylic acid is here, and formic acid is here. Now we have learned that when you go left to right in a period, the electronegativity will, what will happen? Electronegativity negativity will increase with the size decrease. Okay. So now in here you will ask about to order these molecules according to the way that electronegativity increase. So you will ask to write these molecules. Now in here, the all middle atoms, okay, all center atoms are carbon. In here, carbon is the center atom. In here, again, carbon is the center atom. In here, again, the carbon is the center atom. In here, carbon is the center atom. Now we cannot use the previous theory on that. In previous theory, what we learned, the electronegativity will decrease. Electronegativity will increase when you go from left to right in a period. So that means electronegativity of oxygen is greater than nitrogen, because Nitrogen is kind of because the size of oxygen is less than nitrogen, so electronegativity increase. Okay, so that is something we have learned in the first lesson. Okay, now in here all atoms are carbon, and in here all atoms are carbon. Okay, so you can't decide which one is which carbon has higher electronegativity, because as we learned in previous lesson, the electronegativity of all carbons are same. No, electronegativity of all carbons are same. But in here, you can't distinguish these molecules looking at the center atom, because all are carbon. So there's a theory. There's a theory how you going to define which carbon, which molecule, which carbon in which molecule has higher. I'm sorry, which molecule? No, all the center atoms are carbon, right? So which molecules had the higher electronegativity? Now let's see what is the theory. So when you are going to determine the electronegativity of a same atom in a different molecule, okay, but listen very carefully. Okay, this is very, very important. When you are going to determine the electronegativity of, listen carefully, same atom, see, carbon, same atom in a different molecules, there's a theory. Okay, first you have to decide the hybridization. Now these factors, by these factors, the electronegativity will be varied. Okay, hybridization. First factor is the hybridization. Second factor is the charge. And the third factor is the oxidation number. And the fourth factor is the nature of neighboring elements. Okay, by using this theory, we are going to determine which carbon has higher electronegativity. Now, something you should really keep in your mind. When you are going to determine which carbon has high electronegativity, you have to follow the exact order. Do you know what I mean? First you have to consider hybridization. So we have to separate these by hybridization. If we cannot separate a certain two molecules by hybridization, then you have go for the charge. Then if you cannot separate them by both hybridization and charge, then you have go for the oxidation number. If you cannot separate them by each of these, you have to go to the nature of neighboring atoms. Okay, now see how electronegativity is defined by using these four factors. Now let's talk about the hybridization. The S percentage of hybridization. The S percentage of hybridization increased, the electronegativity will increase. Okay, the S percentage of hybridization. When the S percentage of hybridization increase, the electronegativity will increase. So let's see about now when we talk about sp hybridization. What is the percentage of S here? 50%. There are two hybridized orbitals and one. Then percentage of S is 50%. Now when you go sp2, there are three hybridized orbitals, and here 1, here 2 and 3, and S is 1 out of 3. In here it's 50%. In here it's 33.33%. Now let's say sp3. You got 1 S and 1. You have 4 hybridized orbitals 1s, and here 1s and 3p. That means 4 orbitals, and out of 1 out of that 4 is s, so it's 25%. 25%. Okay. Now, when the what is the theory said? When the s percentage of hybridized orbital, when the s percentage of increase in a hybridized orbital, the electronegativity will increase. පැහැදිලිද? Can you understand? මේ කියන්නේ මේ s s orbital එකේ contribution එක වැඩි වෙන විදිහට, වැඩි වෙන තරමට එයාගේ electronegativity එක වැඩි වෙනවා කියලා. Okay? Okay, right. Now see here, what is the hybridization of here? It is, see, there are 4 sigma bonds, so it is sp3. In this carbon, the hybridization is sp3. How are we going to determine the hybridization? You have to count the sigma bonds and valence pair. Okay, sigma bond and the valence electron pairs. So you have 4 sigma bonds, that means sp3. In here, CO2, you have 2 sigma bonds, and it's a sp. Okay. Can I draw? Okay, can I draw their structures? So CH4, you got like this. And CO2. Okay, and this is okay. Let's see how to, yeah, that's fine. These two are fine. So here you have 4 sigma bonds. So the hybridization of this one is sp3. So in here you have 2 sigma bonds. So hybridization of this carbon is sp. And here you got 1, 2, 3 sigma bonds. So the hybridization is sp2. In here you got 1, 2, 3 sigma bonds, and the hybridization is sp2. Okay. So now first what what is the process? Now we are going to determine which carbon in which molecule has higher electronegativity. Okay, higher electronegativity. So first factor we should concern is hybridization. Now considering hybridization, you can see CH4 has sp3 hybridization, so S percentage is 25%. And CO2 has sp hybridization, and the S percentage 50%. And acetic acid have sp2 hybridization, and the S percentage is 33.33%. And here same sp2, that S percentage is 33.33. Okay, now let's see. Okay, now considering the hybridization, this one has higher electronegativity because it has sp. The percentage of S is 50%, and CH4 has the least electronegativity because it has sp3 hybridization in carbon, that is S percentage 25%. So we can write CH4 is the least one and CO2 is the greater one. CH4 is the least one and CO2 is the great one. Now you cannot separate acetic acid and formic acid. These two molecules, they have same hybridization. So by looking at hybridization, you cannot separate these two molecules. Okay, you cannot determine which molecule has higher electronegativity looking at the hybridization. By looking at hybridization, now we have decided that CH4 has the least electronegativity because its hybridization is sp3, which means the S percentage is 25%, and CO2 has the highest electronegativity because its hybridization is sp. The S percentage is 50%. Okay, now we have to do you have to separate. You have to determine which of this carbon has high electronegativity. Now you cannot use hybridization in here because it has same hybridization. Okay, can you understand? Okay, you can't උතන කියන්නේ මේ දෙක වෙන් කරන්න බෑ hybridization එක දිහා බලලා because both them have same hybridization. Okay, all right. Now if you cannot separate them by hybridization, you have to go to number 2. What is number 2? Number 2 is the charge. Number 2 is the charge. Now none of these molecules have none of these atom has a charge. So make a charge එකක් නැහැ නේ කාගේ. There's no charge. All are neutral. So you cannot use charge to separate them. Then number 3 is oxidation number. Oxidation number. Now what is the oxidation number of this carbon? See, there is a CC bond. Okay, in electron goes this way by the in here. So it is +1 and 2 electrons go there and it has 3 + 3. So the oxidation number is +3 in acetic acid. Okay. Now here, in here, what is the oxidation number of carbon? Here +1, +1, +2, plus here +1, +2, +3, and electrons come this way. So it has +2, +2. Okay. So again, I'm telling you, you cannot separate this by hybridization. So we are going for the number two factor, that is the charge. So charge is there's a note. None of these molecules have a charge, so you cannot use charge to separate these molecules by from each other. So we go on to number 3. That is the oxidation number. That is oxidation number. Okay. Now oxidation number. This one has +3 oxidation. Now +3, and this one has +2. Now, what is the theory said? When the oxidation number is greater, the electronegativity is greater. When the oxidation number is greater, the electronegativity is greater. So when you are comparing the acidic acid and formic acid, this one has +3 oxidation number, and this has +2 oxidation number. So greater the oxidation number, greater the electronegativity. So CH3COH come here, acidic acid come here, and formic acid come here. Okay, all right. Now we have determined the answer. This is the way that electronegativity is increase of these molecules. So this is very simple one. Okay, so only thing you should remember is you have to consider the factor, the exact order that I mentioned you. The exact order. First, you need to consider the hybridization. That is how we determine that CH4 has the least electronegativity and CO2 has the highest electronegativity. The number, okay, but we are unable to separate these two molecules looking at their hybridization. So then we have to go for the number 2 factor. What is the number 2 factor? Is the charge. So none of these molecules have a charge. Okay, so you cannot separate by them charge. So I'll tell you what happens if there's a charge. If the charge is positive, and that positive charge is greater, okay, if the charge is positive and the positive charge is greater, the oxidation number is greater. Okay, so now think about there is a molecule with neutral and a positive charge. So the molecule with the positive charge for the central atom will have higher oxidation number. හරිද? කියන්නේ neutral එකකුයි charge එකක් positive charge එකක් තියෙන එකකුයි ගත්තොත් එහෙම අර positive charge එක යාගේ තමයි electronegativity එක higher. And if there is a two molecules has a positive charge, so දෙන්නටම positive charge තිබ්බොත් the higher positive charge, okay, the molecule which higher positive charge has the higher electronegativity. That's how we are defined through positive charge by the charge. Okay, so none of these two molecules have a charge, so we cannot use electronegativity by charge. We have to go number 3 factor, which is oxidation number. What does the theory say? The greater the oxidation number is, the greater the electronegativity. So in here +3 1, So it has, we are going to compare these two. So this one has higher electronegativity because they have higher oxidation number. Okay. So now we can get the answer. If you are unable to separate by using oxidation number these two, then you have go for the number for the nature of the neighboring atoms. So what will I'll tell you what is that means. If the neighboring atoms have higher electronegativity, that central atom also have higher electronegativity. Let's get here. Let's think about CF4 and CCl4. When you compare CF4 and CCl4, both these carbon have same hybridization, sp3, same hybridization, and there's no charge. None of these molecules have charge. And number 3 is oxidation number. Both these carbon have same oxidation number, that is +4 and +4. So you cannot separate by oxidation number. The last factor is the nature of neighboring atoms. Here, fluorine has higher electronegativity than chlorine. Fluorine has higher electronegativity than chlorine. So the electrons are attract towards fluorine than chlorine. So this carbon have higher electronegativity. Okay, can you understand? So මේ වටේ ඉන්න අයගේ nature එක තමයි බලන්න ඕනේ. Okay, හරිද? Now fluorine electronegativity එක fluorine මේ carbon දෙන්නගේ electronegativity එක තමයි අපි compare කරන්නේ. So fluorine electronegativity එක වැඩි chlorine ට සාපේක්ෂව. So what will happen? The fluorine will attract more electrons than carbon. The electronegativity is this CF4 carbon. This has a higher electronegativity. Okay, I think you have understand properly now. Now let's go for some exercises and some questions that asked from past paper questions. Okay, let's go for that. Okay, right. Okay, let's go for that. All right. Okay, turn the page 5, no? Okay.